College Algebra, Module 4, Topic 4.3, Absolute Value Equations and Inequalities. Absolute value is the distance a number is from zero on a number line. The absolute value of a real number is never negative, that is, it's always greater than or equal to zero. It's simply the number part ignoring the sign. An absolute value is denoted by two vertical bars. For example, the absolute value of 5 means the distance from 5 to 0 on a number line, which would just be 5. Whereas the absolute value of negative 5 is the distance from negative 5 to 0 on a number line, which would be positive 5. Objective 1. The absolute value equations. Before we begin solving absolute value equations, consider the following. The absolute value of x is equal to 3. What that means is the absolute value of what number is 3, or in terms of a graph, what number is 3 units from 0. Well, if this is 0, then 3 units to the right of 0 would be 3. Or we must also consider 3 units to the left, which would be negative 3. Therefore, we have two solutions. X is 3 or x is negative 3. Consider the equation the absolute value of x equals negative 2. Well, that means the distance between this number and 0 is negative 2. Well, you cannot have a distance of negative 2, therefore we say that this equation has 0 solutions. And then the third example, the absolute value of x equals 0. On a number line, that means what number or numbers are 0 units from 0? Well, that's the only one number, so that would be 0, and there is one solution to that equation. So, if we have the absolute value of an expression equaling a positive number, we're going to have two solutions. If we have the absolute value equaling a negative number, there will be no solutions. And if we have the absolute value equals 0, then we're going to have one solution. Let k be a positive number. To solve an equation of the form the absolute value of ax plus b equals k, solve the compound equation ax plus b equals k, or ax plus b equals negative k. Think back to our example on the previous page. If we had the absolute value of x is 3, that means what number is 3 units from 0? Well, we said it was either 3 or negative 3. So what this is saying is the absolute value of ax plus b is equal to k. That means it's either k units on the right side, which would be a positive k, or k units on the left side, which would be negative k. For example, solve the equation the absolute value of 2x plus 1 equals 7. That means the distance between 0 and 2x plus 1 is 7. So our choices are 2x plus 1 to be 7 on the positive side, or 2x plus 1 has to equal negative 7 on the other side. Now we're going to solve both of these. So for the first equation, we're going to subtract 1. So we get 2x is 6. Divide both sides by 2. And we get x is 3. For the second equation, we get minus 1 on both sides, so we get 2x is equal to negative 8. Divide both sides by 2, so x would be negative 4. So our solutions are x is 3 and x is negative 4. Now to check that, we would go back and plug in those numbers for x. So for the first one, we've got 2 times 3 plus 1 inside the absolute value bars, which would give us 6 plus 1. So we get the absolute value of 7, which is 7. To check the second one, we get 2 times negative 4 plus 1, which is negative 8 plus 1, so we get the absolute value of negative 7, which is also 7. So our solutions are 3 and negative 4. Okay, let's do another one. Solve the absolute value of negative 3x is equal to 12. Well, the same thing. We've got an absolute value equation equaling to a positive number. So what that means to get rid of the bars is negative 3x is equal to 12, or negative 3x is equal to negative 12. Well, if negative 3x is 12, divide both sides by negative 3, and we get x is negative 4. The second side, divide both sides by negative 3, and we get x is equal to positive 4. So our solutions would be 4 and negative 4. Okay, let's do another one. Now this time it's a little bit different because we've got the absolute value of x plus 2 equals 4. Well, in order to solve an absolute value equation, the first thing we want to do is get the absolute value bars on a side by themselves. Okay, once we get the bars on a side by themselves, then we're going to do the two cases to get rid of the bars. One case is just like it is without the bars. The second case is leave one side alone and change the sign on the other side. So for this one, we're going to have minus 2, so we've got to get the bars on the side by themselves, so we'd get the absolute value of x is equal to 2. Well, this goes back to our first example. The first case is just like it is with no bars, which is x is equal to 2. The second case, you leave one side alone, and then you change the sign of the other side. So we get x is equal to 2, and x is equal to negative 2. Now remember, it's very important on this first step to move that plus 2 over before attempting to do the two cases to remove the bars. This time we're going to solve the equation the absolute value of 3x minus 4 equals 7. Well, we've got the bars on the left side by themselves, so we're ready to do the two cases. So the first case is just like it is, no bars. Or the second case, leave one side the way it is, but change the sign of the other side, so we would get 3x minus 4 equals negative 7. So the first equation, we're going to add 4 to both sides, so we get 3x is equal to 11. Divide by 3, and we get 11 over 3. Second case, we're going to add 4 to both sides, so we get 3x is equal to negative 3, or x is equal to negative 1. So there's our solutions, 11/3 and negative 1. Okay, one more. Solve the equation, the absolute value of 2x plus 4 plus 5 equals negative 1. In order to solve an absolute value equation, you need to get the bars on a side by themselves. So the first thing we're going to do is subtract 5 from both sides. So we get the absolute value of 2x plus 4 equals negative 6. Well, we can do just like what we were doing, two cases. 2x plus 4 equals negative 6. The first case is just like it is with no bars. The second case, leave one side alone, change the sign of the other side. Well, when we go through and solve the first side, we get 2x is equal to negative 10. Divide by 2, so x is negative 5. Second case, subtract 4 from both sides, so we get 2x is equal to 2. Divide by 2, and we get x is 1. But what I want you to notice is when we go back and check these, if we go back and plug in negative 5, that would give us the absolute value of negative 10 plus 4 plus 5, which would give us the absolute value of negative 6 plus 5. Well, the absolute value of negative 6 is 6, Well, do you notice that 6 plus 5 is not equal to negative 1? Therefore, that solution does not work. If we did it for 1, we would get the absolute value of 2 times 1 plus 4 plus 5. Well, that would give us 2 plus 4 inside the bars. So we'd get the absolute value of 6 plus 5. Same thing, we get 6 plus 5, which is 11, which is not equal to negative 1. So what we need to go back and look at is, you notice right here when we got the bars on the side by themselves, we had that the absolute value was equal to a negative number. What that tells us automatically is that this equation does not have a solution because absolute value can never equal a negative number. Okay, now I want to show you how you can use your graphing calculator to solve an equation involving absolute value. So we are going to solve the equation, the absolute value of 2x plus 1 equals 7. Well, remember, to solve an equation on your calculator, you want to let the left side of the equation be equal to y1. You want to let the right side of the equation be equal to y2. You're going to graph those. You're going to make sure you can see where they intersect on your calculator. Then you're going to calculate that intersection point. So for y1, we're going to let it be the absolute value. So we are going to do math. We're going to slide to the right one place to where it says number, and then absolute value is number 1. So the absolute value of 2x plus 1, close that parenthesis. Then we're going to arrow down to y2, and y2 is going to be 7. Well, I'm going to go ahead and hit zoom 6 to get us on our standard screen. So there's what our graph looks like. The first one is our absolute value graph, which is usually a V-shaped graph. The 7 is the horizontal line through 7. Notice there are 2 points of intersection, so we are going to have 2 solutions. So let's say we're going to do the first one. So we're going to do second trace, which is calculate. Number 5 is the intersection. Then we're going to do enter, enter, enter to get our calculation. And we get the first ordered pair is 3, 7. So our solution is the x value of the intersection point. Now we're going to do it again. Now this time we've got to find this one over here. So we're going to do second trace, number 5, enter, enter. Now if I hit enter again, it's going to give me the same answer. So what you want to do the second time through is enter for the first curve, enter for the second curve. But notice when it says guess, it's always going to guess the intersection closest to the cursor. So at that point you want to arrow over, put your cursor on the other point, which gives us the ordered pair negative 4, 7. So our 2 solutions are 3 and negative 4. Now let's talk about equations with 2 absolute values. To solve an equation of the form, the absolute value of ax plus b is equal to the absolute value of cx plus d. We're going to solve the compound equation ax plus b equals cx plus d, which is just like we had earlier. The first case is just like it is without the bars. Or the second case, ax plus b equals the negative of cx plus d, which is what I told you earlier. The second case is one side is just like it is without the bars. The other side you change the sign. For example, we're going to do the absolute value of x plus 6 equals the absolute value of 2x minus 3. So the first case is just like it is without the bars. X plus 6 equals 2x minus 3. The second case, leave one side alone, which would give us x plus 6, and then we're going to change the sign on the other side. Now notice it's just not changed this middle sign. We're going to change the sign of the whole side, which is going to be x plus 6 equals negative 2x plus 3. So here's our 2 equations. So let's go back to the first case. we want to get x on the side by itself, so we're going to subtract x from both sides, so we get 6 equals x minus 3. We're going to bring the numbers to the other side, so we get x is equal to 9. Or the second case, we're going to add 2x to both sides, which gives us 3x plus 6 equals 3. Subtract 6 from both sides, so we get 3x is equal to negative 3. Dividing both sides by 3 gives us x equals negative 1. So our solutions would be negative 1 and 9. We could go back and check it. If we plug in negative 1 on both sides, we get negative 1 plus 6, which is the absolute value of 5 on one side. On the other side, we get 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. Well, the absolute value of 5 is 5. The absolute value of negative 5 is 5. So that one checks. And then we can do exactly the same thing for 9 to show that we get 15 on both sides. Now, this one has two absolute values in it, but it's also got just a regular number, so we're just going to solve this one graphically on our graphing calculator. Okay, so just like I told you earlier, anytime we want to do this on our calculator, let the left side of the equation be y1, let the right side be y2. So to do this on our calculator, we're going to do the absolute value, which is math, slide to number, choose number 1 for absolute value of x plus 5. Then we're going to close that parenthesis, plus, then we're going to do it again. Math, slide to number 1 is absolute value of x minus 3, and then the right side is going to be 16. Well, when we graph that, there's the left side, but the problem is 16 is not in this window from negative 10 to 10, so we can go to our window. We need it to be at least 16 high, so I'm going to go down to our y max and change it to 20. And then when we press graph, there's our graph, there's our 16. We can tell by looking at our picture that we've got two intersections. The first one's here, the second one is here. So we are going to do second trace, which is calculate, number 5, enter, enter, enter for the first curve, and we get the ordered pair 7, 16, which means x is equal to 7 is our first solution. Then we're going to do it again. Second trace, which is calculate, number 5, enter for the first curve, enter for the second curve, but remember on the guess, we want to guess closest to the point that we're looking for, so we're going to move our cursor and put it on the other intersection, which would give us negative 9. So the other intersection is negative 9, 16, which means that the other solution is negative 9. So our answer for this problem would be x is equal to 7 and x is equal to negative 9. Okay, objective 2 is absolute value inequalities. Now, we're going to solve each inequality graphically, and then we're going to write our answer in interval notation. Well, think about absolute value. This means the absolute value of what number is less than 5. What number is less than 5 places from 0 on your graph? Well, if this is 0, 5 places to your right is positive 5. 5 places to your left is negative 5. So all of the numbers between negative 5 and 5 have a distance from 0 that's less than 5. So the way we're going to write that is interval notation. Now because it's or equal to, we're going to shade both circles. And remember, interval notation, you start reading at the left, so it would be from negative 5 to positive 5 and all values in between. Now the second one is the absolute value of x is greater than 2. This means the distance from what number and 0 is greater than 2. Well, let's look at our graph again. If this is 0, Well, we know this is 2 places from 0 to the right. -2 is 2 places from 0 to the left. So if you're looking for all numbers whose distance is more than 2, that means it's from 2 to the right this way. Or it means it could be from -2 to the left the other way. So in interval notation, what we've got is the first piece is from -infinity up to -2. Put a parenthesis because it does not include the 2. Or then it starts again at 2 and it goes all the way to infinity. For absolute value inequalities, let's do it again. Let k be a positive number. To solve an inequality of the form, the absolute value of ax plus b is greater than k, you're going to solve the compound inequality ax plus b is greater than k, or ax plus b is less than -k. Again, think about this. This means the distance from 0 is greater than some number, which means it's either greater than this way or less than this way. For example, let's solve the inequality. The absolute value of 2x plus 1 is greater than 7. So what that means is 2x plus 1 is greater than 7, or 2x plus 1 is less than -7. And what we're going to find out is anytime we have the absolute value is greater or, then it's going to be two pieces of the graph. So let's solve this one. The first piece, we're going to subtract 1 from both sides, so we get 2x is greater than 6. Divide by 2, so we get x is greater than 3. Or the second piece, we're going to subtract 1 from both sides, so we get 2x is less than -8. Dividing by 2, we get x is less than -4. So for our graph, we're going to locate -4 and 3 on a number line. First piece is x is greater than 3. Greater than, remember, is an open circle because it does not include 3. The second piece, x is less than -4. Again, it's an open circle, but this time less than means we're going to the left. Now, interval notation, reading from the left, is from -infinity to -4, or from 3 to infinity. What that means is if you pick any number less than -4 or any number greater than 3 and plug it in, we're going to get an absolute value that's greater than 7. Now the other case is this. Let k be a positive number. To solve an inequality of the form, the absolute value of ax plus b is less than k, solve the compound inequality ax plus b is less than k, and ax plus b is greater than -k, which is equivalent to the expression -k is less than ax plus b is less than k. Now think about this one again. This means the distance from this expression and 0 is less than k, which means on our number line that it was between -k and k, which is what this expression means, is that ax plus b is greater than -k but less than k. Let's do one of these examples. Solve the inequality. The absolute value of 2x plus 5 is less than 3. Well, absolute value is less than 3, which means the distance between 2x plus 5 and 0 is less than 3. So what we've got is we've got 2x plus 5 is less than 3, and 2x plus 5 is greater than -3. Now if we go back to what we were doing, the first case is just like it was with no bars. You simply remove the bars. That was this first case. The second case is leave one side alone, which we did. Then you're going to change the direction of the sign and change the sign of the number. Okay, so it's sort of like what we did back when we were doing equations. First case, no bars. Second case, leave one side alone and change the sign of one side, except now we're going to change the inequality sign as well. If we solved it as two separate cases, we'd get minus 5 on both sides, so we get 2x is less than negative 2, which means x is less than negative 1. If we solve the second case, we get minus 5 on both sides, so we get 2x is greater than negative 8, which means x is greater than negative 4. Now if we look at this graph, we've got negative 1 and negative 4. So if we put them in order from smallest to largest, x is less than negative 1 is from negative 1 all the way back. X is greater than negative 4 is from negative 1 all the way forward. Now remember we said an AND is only that piece of the graph that satisfies both of those, which if you'll look is only this little set of numbers between negative 4 and negative 1. So our solution would be negative 4 to negative 1 in parentheses because neither of the endpoints were included. Now, we could also have just set it up as this double inequality, which means 2x plus 5 is between 3 and negative 3. And remember, to solve an inequality like this, our goal is to get x in the middle. We're going to subtract 5 from the middle, but we also have to subtract 5 from all three pieces, so we get negative 8 is less than 2x is less than negative 2. Now we're going to divide the middle piece by 2, which means we have to divide all the pieces by 2, so we get negative 4 is less than x is less than negative 1, which is exactly what we've got shaded, all x values between negative 4 and negative 1. Now, the inequalities I've been showing and the ones that we're going to do may involve less than, greater than, less than or equal to, or greater than or equal to, but we're going to solve them all the same way. So as a summary, if the absolute value of x is equal to a number, then x is equal to that number or the negative of that number. If the absolute value of x is less than k, less than means and, okay, less than and, greater or. If the absolute value of x is less than k, then x is less than k and x is greater than negative k. If the absolute value of x is greater than k, then x is greater than k or x is less than negative k. Notice in all three cases, the first case, the first equation is just like the original problem with no bars. The second case, we change the sign of the other side, and if there's an inequality sign, then we reverse that sign. Okay? Let's do objective 3, solving special cases. Well, the first example, the absolute value of 3x plus 5 equals negative 5. Do you notice that example? You've got the absolute value equaling a negative number. You cannot have absolute value equaling a negative, so automatically we can say no solution. The second example, the absolute value of 3x plus 5 is less than negative 5. Remember we said that the absolute value is the distance from 0. You are never going to have the distance being less than negative 5. Therefore, again, that one is not going to have a solution. Then the last one, the absolute value of 3x plus 5 is greater than negative 5. Well, remember we said the absolute value is the distance. Distance is always positive or 0. So the distance of 0 or any positive number is always going to be greater than negative 5. So what that means is this equation, or this inequality, is all real numbers. It doesn't matter what we put in there. When we take the absolute value of it, it's going to be greater than negative 5. Okay, let's look at these on our calculator real quick. And I'm going to start out just by showing you, let's look at the absolute value of 3x plus 5 equals 5. So the first thing we're going to do is math, slide to number, there's absolute value of 3x plus 5. So for the first example, I'm just going to put 5. We're going to go to zoom 6 to square it up. There's our absolute value. There's our 5. Notice there are two solutions. They're going to be right here to the left and right here on the right. So we are going to say second trace, which is calculate. The intersection is number 5. Enter, enter, enter. And the first solution is 0. Then we're going to do it again. Second trace, number 5. Enter, enter. The second time we're going to put our cursor on the other intersection, and we get negative 3.333, which would be negative 3 1/3. Now, for the real example, we had the absolute value of 3x plus 5 stays the same, but the y2 is going to be negative 5. Well, when we graph that, there's our absolute value, there's our negative 5. You notice they never intersect, they never will intersect. Therefore, this one was no solution. Now the next part, the absolute value of 3x plus 5 is less than negative 5. Well, remember we said we want to look where y1 is less than y2. Well, in this picture, y1 is never below y2. That's why we say that it is also no solution. Then C part, the absolute value of 3x plus 5 is greater than negative 5. This time we want to look where y1 is above y2. Well, notice everywhere in the picture y1 is going to be above y2. Therefore, this solution was all real numbers. Now, these next couple of examples are going to be absolute value inequalities where there is more than one set of absolute value bars. What I want you to do is only do these on your calculator. I just want you to be able to pull off these intersection points. So the first one is the absolute value of x plus 6 is less than the absolute value of 2x minus 3. Well, we're going to graph where y1 is less than y2. So on our calculator, y1 is going to be math, slide to number of, choose absolute value of x plus 6. y2 is going to be the absolute value, math, number 1, of 2x minus 3. Now when we graph those, there's the first graph, there's y1, there's y2. So we want to find where the first graph y1 is below y2. Well, from everywhere from here back, y1 is going to be below y2. So it's from this intersection, over. And then also, once these two graphs intersect again up here, you notice y2 is going to be above y1 again. Let's zoom out just a little bit. This time I'm just going to zoom out, so I'm just going to go to zoom out, enter. So there's the first one, there's the second one. I'll tell you, I'm going to change it just a little bit. Let's go back to y1 for a second. Do you see over at the total left side, it's just got the little line? If I press enter, that's going to change that to a little bit darker line. So when we graph it now y1 is the heavy line, y2 is the light line. So we are looking where the heavy line is below the white line. So it's from here all the way back this way, and then it's also from this intersection all the way over. So we need these 2 points of intersection. So we are going to do second trace, number 5, enter, enter, enter for the first curve. So our first one is x is negative 1, y is 5. So our first point of intersection is negative 1. Our second point of intersection, second calc number 5, enter. Remember, we're going to move our cursor over closer to the other intersection. So the second intersection is 9, 15. So the two solutions for x values are -1 and 9. So everywhere to the left of -1, y1 is below y2. Everywhere to the right of 9, y1 is below y2. Because this is just less than, we're going to use open circles. So our solution would be, for the first inequality, from -infinity to -1, or from 9 to infinity. For the second inequality, it's the absolute value of x plus 6 is greater than or equal to the absolute value of 2x minus 3. This time what we've got is y1 is above y2. Well, the only piece of the graph where y1 is above y2 is this little piece right here between -1 and 9. Now, because it's or equal to, that means it includes those points. So we are going to say that the solution is the interval from -1 to 9, including both endpoints. Now, do you remember how we could check those? We would just enter the absolute value of x plus 6. If we were doing the first one, we would say second math less than is number 5. Then we're going to go math number 1 of 2x minus 3. And then we don't need the y2 anymore. Well, when we graph this, I'm going to go back to zoom 6 because I can't see that very well. Notice it shows the shading for everywhere below -1 and everywhere above +9. Okay, one application. The inequality, the absolute value of x minus 48 is less than or equal to 21, describes the range of average monthly temperatures x in degrees Fahrenheit for Spokane, Washington. Solve this inequality and interpret the result. Well, first thing we do for an absolute value inequality is we've got to get rid of those bars. So we start out and we say absolute value is less than. Less than is and. So to do this, we're just going to put x minus 48 between -21 and +21. So we'd get -21 is less than or equal to x minus 48 is less than or equal to +21. Now to get x in the middle, we're going to add 48 to all sides. So we would get 27 is less than or equal to x is less than or equal to 69, which means that x is the monthly temperature is between 27 and 69. So what this means when we interpret is the monthly temperatures for Spokane, Washington are anywhere between 27 degrees Fahrenheit and 69 degrees Fahrenheit. You are now ready to do the homework for Module 4, Topic 4.3 in my math lab. Once you have scored at least a 90%, you are now ready to do the homework for Module 4, Topic 4.3 in my math lab. Once you have scored at least a 90% on all of these homework sets, you'll be ready to take the Module 4 quiz. Remember, you must have notes from all sections in order to take the quiz.